Myself, Dr. Mehrajuddin Bhatt, Assistant Professor from the Department of H&S, Marri Laxman Reddy Institute of Technology and Management. In the previous lectures, we have started with the module 3rd, that is polymeric materials. In the first two lectures, we have discussed the introduction of polymers, classification of polymers. Then we have discussed polymerization, types of polymerization. We have discussed addition polymerization. Today we will discuss one more topic, that is what we call as condensation polymer. So students, let me start. The contents of today's lecture are condensation polymerization and copolymerization. We know polymers are macromolecules, or we can say large molecules that are made by the combination of smallest units known as monomers. These smallest units, monomers, combined together through covalent bonds made large or macromolecules known what we call as polymers. So we will start with the lecture that is known what we call as condensation polymerization. Condensation polymerization is also known what we call as stepwise polymerization. This condensation polymerization occurs between monomers that contain polar groups. It means those monomers with polar groups combined together form condensation polymerization. In condensation polymerization, the reaction occurs between same or different polar group containing monomers with the elimination of small molecules like ammonia, water, hydrochloride, etc. And they form linear cross-linked polymers. This type of polymerization with the elimination of smaller molecules like ammonia or water by the combination of same or different polar monomers are known what we call as condensation polymerization. The molecular weight of polymer is not the integral multiply of molecular weight of monomers. The chemical composition of monomer and polymer are different. In condensation polymerization, the chemical composition of the polymer results by combining of same or different polar monomers are different. The byproducts, condensation polymerization occurs with the elimination of smaller molecules like water, ammonia, and hydrochloric acid. These are known what we call as byproducts. Water, ammonia, hydrochloride, and hydrogen cyanide, etc. The condensation polymer results in the formation of linear cross-linked three-dimensional network of polymers. The example of condensation polymerization is Nylon 66. This is the most important polymer that we discuss here. Nylon 66 is formed by the condensation polymerization. And the monomers of nylon 66 are hexamethylene diamine and adipic acid. These two are the monomers of nylon 66. Synthesis of this nylon 66, it is prepared by the condensation polymerization. Nylon 66, Wallace Carother patented nylon 66 with the use of MLRITM. This nylon 66 is formed by the condensation polymerization of two polar group monomers. One is hexamethylene diamine and another one is adipic acid. Like this. This is adipic acid. This is hexamethylene diamine. These are the polar monomers because they have polar functional groups. Like this is one polar functional group. This is the polar group. This is polar and this one is polar. That is why these are known as polar monomer units. They combine together to form nylon 66 with the elimination of the smallest molecule, that is known what we call as water. Water here is the byproduct and this one is what we call as nylon 66. What are the properties of nylon 66? Nylon 66 is lustrous. It is elastic. This nylon 66 is very strong. It is damage resistant to oil and many chemicals. That means nylon 66 is not damaged by the oils and chemicals. It is resilient. Nylon 66 does not absorb water. It also dries very quickly. These are some of the properties of nylon 66 that make nylon 66 very important condensation polymer that we use in day-to-day life. What are the uses of nylon 66? Nylon 66 is used in clothing. It is used in shirts, foundation garments. We can use nylon 66 in raincoats. We can use it in underwear, swimwear, and cycle. There are some important industrial uses of nylon 66, that is conveyor and seat belts. We can use it in parachutes, airbags, nets and ropes, threads. Nylon 66 is also used to make fish net. It can also be used as a plastic in the manufacture of machine parts. These are some of the uses of nylon 66. The second example of condensation polymerization is synthesis of terylene. We can say it as dacron. This is the condensation polymerization. Students, we know condensation polymerization is a process of polymer formation in which same or different polar monomer units combine together with the elimination of the smallest molecules like water, ammonia, hydrogen chloride, and hydrogen cyanide. Terylene is one of the types of this condensation polymerization. First, we should know the polar monomers of this pterylene. Polar monomers of this pterylene. The condensation polymer pterylene is formed by the polymerization of ethylene glycol and terephthalic acid. We can say it as pterylene. The condensation polymer pterylene is produced like this. This is ethylene glycol, and the second polar monomer is terephthalic acid. Polar groups. In condensation polymerization, the monomers contain the polar groups. This is terephthalic acid and the polar groups of these carboxylic acid. And in ethylene glycol, there are also polar groups, OH and this OH. And it can form pterylene. It is a synthetic polyester fabric and can be used in the variety of cloths. Its chemical formula is C10H8O4 N times, and N time is C10H8O4. These condensation polymerization, or we can say this condensation polymerization pterylene is formed by the combination of ethylene glycol and terephthalic acid pterylene. Synthesis. Now we can discuss the synthesis of this diagram. This was the synthesis of diagram. Now we can discuss the properties of pterylene. Since it is a strong fiber and can be used for bleaching and dry cleaning. The bleaching and dry cleaning reagents has no effect on it. We can say pterylene is a very strong fiber. Bleaching and cleaning agents does not affect it. It absorbs very little amount of water, so that we can say it dries very quickly. And it can be washed very well. Pterylene is resistant to friction because of its high tensile strength. Pterylene has high tensile strength. Pterylene is also very stable at high temperature. It is resistant to acid and base, as it is insoluble in most of the organic solvents. Pterylene is a synthetic polyester which in mixing with wool is known as terry wool. If we mix the synthetic polyester pterylene with wool, it is known what we call as terry wool. These are certain uses of pterylene. Pterylene fiber is used as a polyester, tricotinate, as a fashion garment fabrics. We can use pterylene in making plastic bottles. Pterylene can also be used to make hardware cloths like dresses, toastery, fleece jackets, dress materials in various textile industries. Pterylene can also be used by exhibition purposes. For exhibition purpose, non-woven needle punched carpets are made with the help of pterylene. Terylene can also be used for laundry purpose as an automatic clothing vacuum packaging machines. Now we will discuss about the second content that is known what we call as copolymerization. What is copolymerization? Copolymerization is defined as the process of polymerization in which two or more different monomer units undergo simultaneous polymerization. It is known what we call as copolymerization. The properties of copolymer are different from those of individual monomer units. When two or different monomer units combine together simultaneously, they form copolymer. This copolymer has properties that is different from its monomer units. The copolymer may be alternating, it can be random, it can be blocked, and it can be a graft polymer. Example of copolymer is styrene butadiene rubber, SBR. It is styrene butadiene rubber, or we can say Buna S rubber. Buna S rubber is an example of copolymerization. And one more polymerization is known what we call as coordination polymerization. The coordination polymerization is the mixture of transition metal halide and organometallic compound. And the best example is known what we call as Ziegler Natta catalyst. The mixture of transition metal halide and organometallic compound that is known what we call as Ziegler Natta catalyst. This is the formula TiCl, tetrachloride, titanium tetrachloride and triethylene aluminum. This is known what we call as Ziegler Natta catalyst. Here we discuss the differences between the addition polymerization that we have discussed in the previous lecture and the condensation polymerization that we have discussed today. In addition polymerization, monomer has at least one multiple bond. Example is ethylene. The monomer in condensation polymerization must have at least two different functional groups. Example is 6-aminohexanoic acid. Second one, addition polymerization proceeds with chain growth mechanism. It proceeds with chain growth mechanism. In condensation polymerization, we can say the condensation polymerization proceeds by step growth mechanism. In addition polymerization, there are no byproducts. But in condensation polymerization, we defined it in today's lecture. There is the elimination of byproducts like water, ammonia, hydrochloride. In addition polymerization, throughout the reaction, the monomer units decrease steadily. we can say number of monomeric units decrease steadily throughout the reaction. But in condensation polymerization, monomers disappear at the early stages of polymerization. Here in condensation polymerization, monomers disappear at the early stages of the reaction. Molecular weight of polymer in addition polymerization is an integral multiplier of the molecular weight of monomers. As the name defines addition polymerization, the resultant polymer is the integral multiplier of monomer units. But condensation polymerization, the resultant molecular weight of a polymer is not an integral multiplier of monomer. In addition polymerization, high molecular weight polymer is formed at once. But in condensation polymerization, molecular weight of a polymer rises steadily throughout the reaction. These are some of the differences between addition polymerization and the condensation polymerization. We can simply make differences in these types of polymerization processes by simply that in addition polymerization there is no elimination of the smaller molecules, but in condensation polymerization there is an elimination of smaller molecules like water, ammonia and hydrochloride. Here we have mentioned certain books from where we have prepared this PPT for you students. If you want in-depth knowledge of polymers, classification, addition polymerization or condensation polymerization, you can go through these reference books where you can get the in-depth knowledge of the polymeric materials that are very important for the engineering students. So here we end this third lecture that was about condensation polymerization and the definition of copolymerization. This is not the end. See you very soon in the next lecture. Thank you very much for your kind cooperation. Thank you. Thank you.